All right, guys. So, purpose of today's lab is we need to investigate the relationship between radius and speed for an object traveling with uniform circular motion. Okay, the stuff we were talking about last week. Right? So really, the point of this lab is to investigate this. V equals 2 times pi times r over t. Okay? We want to find out what's the relationship between radius and speed for an object traveling with uniform circular motion. Okay? That's the first part of today's lab. The second point of today's lab is my entertainment. Okay? Because I get to watch you whirl these rubber stoppers around and around in a circle and like do all sorts of like crazy movements to try not to get hit in the head with it. It's fun for me. Okay? All right. So the variables in this lab, guys, okay, are listed here. You have to decide which one's the manipulated variable, which one's the responding variable, what are the controlled variables. Okay? So the way the lab works is this, so it can help you to decide which one's which. Okay? We're going to have these tubes, okay, with the strings and the rubber stopper attached. On the other end of the string is a loop, sort of, okay, that you will hang a mass from, okay, and that mass will not be changed throughout the lab. It will stay the same, all right? And I want you to think about maybe why we wouldn't want to change that. Okay. So, by having this mass on here, what is it putting in the string? Tension. Okay. And that tension is keeping the rubber stopper from doing what? Flying off. It's acting as a what? If it keeps it moving in a circle, it's acting as a centripetal force. Okay? We are not changing that centripetal force because we're going to use the same mass throughout the entire lab. All that will change is the radius of the circle. Okay? So we'll start out with a radius of 20, I think. Yeah, 20, 30, 40, 50. Okay? So the radius is obviously measured from the tube to the stopper. Okay? And so, okay, we're going to try a bunch of different radii. Oh, whose class? Oh, so they didn't tell you where they were from? Just said get out? Okay. All right, so you're going to have this set up, okay? And as I said, each time you do this, you're going to have a different radius. Okay, so they start out with your 20, okay, and then 30, 40, 50, okay. Well, there's a knot in that one. 60, okay, and then that'll be the last one, 60. All right, so you're going to have these different radii, okay, and you're going to be whirling it around and around in a circle. The trick is that you cannot hold the string. Because if you hold the string, you can whirl it faster and the string won't move, and that changes the centripetal force. So what you have to do as the whirler, because that's what we're going to make the job title, whirler, okay, you have to be watching the mark on the string and make sure that it doesn't come out further or get sucked back in. It usually doesn't get sucked back in, but it can get out further if you swing too fast. Okay, so you got to kind of make sure, so you kind of start it by holding the string. Then you got to let go of the string and do your best to maintain it, okay, on that radius. Someone else in your group is going to count the number of revolutions. And another member of your group is going to time it. And you're going to time 20, or sorry, you're going to count the number of revolutions in 20 seconds. Right, time for 20 revolutions. So you're going to time 20 revolutions. So one person is going to be counting, okay? One person is going to be timing. So you as the whirler, you don't have to do anything but whirl. That's your only job. You don't have to worry about anything else. Okay? The counter and the timer, they have to work together. Okay? So once you get it consistently going, then it's their job to count and time. Okay? So the person will say go, and then the counter will go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and then stop. And then you can stop as the whirler. Okay, everybody with me? Now, I know that seemed like a lot, but I was doing it all. There's going to be 3 of you doing all of those jobs. Okay? I've done this before. So, everybody follow what you're doing there? Okay, so we're going to use that time, okay, where you're actually going to do 2 trials for each one, for each radius, and then you're going to average them, just for the sake of accuracy. Okay, from there, you can calculate the period. The period measures the length of time for how many revolutions? 1. So, to calculate the period, you're going to take your average time and divide by? How many revolutions did you time? Ooh. Okay. How many revolutions did we time? 20. So you have the time for 20 seconds. Period is the time, sorry. You have the time for 20 revolutions. You need the time for 1 revolution. So if you take the time for 20 and divide by 20, you'll get the time for 1. Everybody follow me? Okay, that's what period is. Then you calculate your speed using v equals 2 pi r over t. Okay, the reason we're doing it that way, we can't measure the speed of this rubber stopper directly. Right? We don't have any instruments to measure its speed directly, so we have to measure its period instead. Okay? Can you wait till I'm done explaining? Or not, if you can't go, but okay. All right. So that's what you're collecting in terms of data. Okay, and then for the analysis, it's basically the first half of it is just filling in this chart. Okay, so doing the calculation for average time, for period, and all that. Okay, and then for number 4, okay, it says identify the force that acted as the centripetal force. Okay, remember, yes, we've got tension in this string, but the tension's being provided by this thing. And whatever might be causing it to want to fall. Okay, and calculate its value. Okay, the big thing here, guys, for answering question number 4, do not use this formula. Okay, that depends on all the stuff we measured and it's not valid. Okay, so calculate the force that might be pulling on this mass another way, since you might know the mass and something else that could allow you to calculate that thing that's pulling it downwards. Okay. All right, and then for number 5, plot a graph of velocity versus radius. Okay, manipulated variable on the x, responding variable on the y. Okay, make sure you get that built, and then tell me what's the relationship between radius and speed from your graph. Is it linear? Is it exponential? Is it inverse? What is it? Okay, just from your graph. Everybody follow there. Okay, and then conclusion, copy paste your hypothesis. Okay, did it work out the way you thought it did? Okay, did we even talk about the hypothesis, or did I skip that? Too many things were going on and I skipped it. Okay, and then evaluation, your 2 sources of error. All right, back to the hypothesis. All right, so for your if, and then statement for your hypothesis, you're talking about what's the relationship. So, okay, predict the relationship. Is it linear, exponential, inverse? Okay, basically, as radius goes up, what's going to happen to speed? Okay, and then in the and part, describe the experiment. In the then part, predict what you're going to see. Maybe the shape of your graph. Okay, would be a good thing to predict. Okay, something like that. Predict what's going to happen. Right? If these things are going to be related this way, what will you see? What will tell you that that's true? Okay, your graph would be your best bet on that. Questions? Okay, now some tips for doing this lab. Okay, pick a part of the room that's not close to stuff. Okay, like the wall. I inevitably have people that they want to put their back to the wall, and then when they get to this point, okay, they start getting really bad data because they keep hitting the wall. Okay, also, it's really tricky if you're trying to see the mark on the top of the tube. Obviously, we need to measure from the top of the tube to the stopper, but a smart person makes that the right distance and then marks at the bottom of the tube, because that you can see while you're whirling it. If you mark at the top, this is where you will have to hold the apparatus in order to see the mark. Do you foresee a problem as the radius gets bigger? mark it at the bottom. Okay, that way you'll be able to see it better. Everybody follow me there? Those are just little tips. Okay, so you're going to need at least 3 people in your group, okay, in order to have a whirler, a timer, and a counter. Okay. All right, so everything you need is up front. Okay, you can just come up and grab it. When you're filling in this chart, I want to see an example calculation for everything that it asks for here. Okay, so for question number 1, where it says each trial average the 2 times, just show me like your first one where you add those 2 times, divide by 2. Okay, same for question number 2, where you're calculating the period divided by 20. Show me that. Okay, show me your calculations for centripetal force. I want to see one example calculation for each one, just in case something goes wildly wrong. I can figure out where you went wrong. Okay, so show your work on all of those. Okay.